Going to do one of the box problems. So the problem states that a rectangular box is constructed by cutting out squares from each corner. The volume of the box is represented by the formula V of x equals x times 10 minus 2x times 8 minus 2x. And as you can see, there is a visual provided of how exactly that box is constructed. So before we even begin the problem, the best thing to do is to label exactly what does your x value represent in this problem and what does your y value represent in this problem. So just kind of looking at this problem, it mentioned that we are cutting out square corners from our box that have the dimension x. And as you saw in class, when we folded up those sides, they eventually became the height of the box. So I know that the x value in this particular problem represents the height. The y value is your dependent quantity. It depends on the height. So what changes as we alter the height? And that is your volume. So whenever you get an ordered pair, when you type this into your calculator, the x value will represent the height and the y value will represent the volume. You will need to use your graphing calculator for this problem. I cannot pull one up on the screen, but if you are watching this, you should follow along with your graphing calculator. Question number 1 asks, find the maximum volume of the box. So when you graph this in your calculator, you should see that your graph should look something like this. The window that I used for this graph, I had a x min of -7, I had an x max of 7, and I did a y min of -60 and a y max of 70. So you should get a graph that looks somewhat similar to this. So when it asks to find the maximum volume of the box, you need to look at your graph and you need to find the maximum point. Obviously, this is a cubic function, so you're going to look for the relative maximum. The relative maximum is located right here. And when looking at this spot, since I want to find the maximum of volume, I need to look at the y value. When I calculate the maximum on my calculator, I get the ordered pair 1.47, 52.51. Now, in this problem, the x value doesn't really matter because this is asking for the maximum volume. So the only thing that I have to put for the maximum volume is the y value, which is 52.51. We'll do units cubed. For number 2, this is when you're going to focus on what the x value is telling us because it wants us to find the dimension of the box at the maximum volume. So when it asks for the dimensions, that means what is the height? It means what is the length? And it also means what is the width? So just looking up at this picture of the box that I have here, the height is going to be our x value, as we mentioned right here. The length is this whole side right here, so I know that this expression 10 minus 2x represents my length, and the width is this side of the box, so I know that this expression 8 minus 2x represents the width of my box. So the height is easy because that is just your x value. So all I have to write for the height of my box was the x value at the maximum point, which was 1.47 units. The length of the box, I'm now going to have to utilize this expression 10 minus 2x. So I will type into my calculator 10 minus 2 times 1.47. The x value that we're using here is the same x value that we got over here. When I plug that into my calculator, I get 7.06 units. So that would be the length of my box at the maximum volume. And then lastly, I'm going to do something similar to figure out the width. I'm going to do 8 minus 2 times my x value, which was 1.47. And when I do that, I will get 5.06 units. So my height is 1.47, my length is 7.06, and my width is 7.06. Number 3 asks us to figure out what is the domain of the function. Domain is x values. So what are the possible x values of this function? As we have talked about before, the x value represents the height of the box. Of the function, it just wants to know what possible x values does this particular graph go to. What's the farthest left? What's the farthest right? You could assume there's arrows at the end of this. So looking, I see that this is going to continue to go left and it is going to continue to go right. So I know that the domain of the function, will simply be negative infinity to positive infinity. For the domain of the problem, it's a little different because we cannot have a negative infinity height all the way to a positive infinity height with just a 10 by 8 sheet of paper. So we have to utilize our graph. We know that this graph represents the volume of the box. I know that all of these x values are heights of the box. Well, obviously, we cannot have a negative volume, nor could we have a negative height. So my graph is only going to be true from this point all the way until this point, because from here to here will give me a positive volume and also a positive height. So all I need to do is figure out what is this x value and what is this x value. So on my calculator, I will utilize the 0 feature. After using the 0 feature, I find that this point right here is the point 0, 0, and this point right here is the point 4, 0. So I know that my function, the height of my function, could only range from 0 to 4. So domain of problem is from 0 all the way to 4. The last problem asks us to find the height of the box at a volume of 40. So as we talked about earlier, volume is a y value. So essentially, this problem is asking us to find x when y is 40. So the way that you are going to do a problem like this is in your calculator in y1, you're going to have your function x times 10 minus 2x times 8 minus 2x. And in y2, you're going to have 40. And what you're going to do is you're going to find the intersection points when you graph these. So if I graph the line y equals 40, I will get a line across my graph like this. And then I could see that this intersects my graph at 1, 2, 3 spots. So I will use the intersection feature, which is second trace, and then you hit number 5 for intersect. I'll use the intersection feature to figure out what these 3 points are. And when I do that, I get x equals 0.71. I get x equals 2.5. 2.40, and I get x equals 5.90. So these are all x values, so in order to make sure that they work for this problem, I have to make sure that they are all in the domain. So looking, 0.71 is in between 0 and 4, so this one is good. 2.4 is also in between 0 and 4, so this one is good. But 5.9 is definitely greater than 4, so this is not part of the domain, so that does not work for this problem. So possible heights for this box at a volume of 40 are 0.71 units and 2.4 units.